This is a quick tutorial to go over limiting reactant problems. I'm going to work one of the problems from the course packet. It's number 7 on page 146 of the course packet. The question gives you a reaction equation, 2 silver nitrate plus 1 copper, solid, yields 2 silvers plus copper nitrate. And we're asked if we're given 20 grams of silver nitrate and 100 grams of copper, what mass of silver is produced. One of the ways that can be really helpful in these is to just organize your data to begin with. So you've got 20 grams of silver nitrate, and you have 100.0 grams of copper. So just write those underneath the reaction equation for which compound or element they belong to. And we're asked what mass of silver is produced. So I'm going to put a question mark in grams underneath silver just to remind me that that's what I am trying to get to. So this is a limiting reactant problem. We know it's a limiting reactant problem because we're given the amounts of 2 different reactants. We have to work the problem twice to figure out how much of the product is actually going to get created. Because what's most likely to happen is that one of these is going to get used up first. Whichever one gets used up first, the reaction shuts down at that point and comes to an end. And that is going to be determine how much of the silver is created. So let's start first with the silver nitrate. So we have 20 grams of silver nitrate. We're going to go to our periodic table and calculate the molar mass of silver nitrate. When you add up the silver, a nitrogen, and 3 oxygens, that's 169.88 grams silver nitrate. And that's how many grams of silver nitrate there are in a mole of silver nitrate. All right, so this is going to follow the same process we've been doing for the last couple days, grams to moles first. Now we're going to do a mole to mole ratio to get from silver nitrate over to silver. So for every 2 moles of silver nitrate, there are 2 moles of silver. And if you wanted to call that 1-to-1, that's fine. I'm just using 2-to-2 to emphasize that those are from the reaction coefficients. Now I'm going to turn that back into grams because that's what we actually need. 1 mole of silver has a mass of 107.86 grams. We crunch that through our calculator and it comes out to be 12.7 grams of silver. All right, so we've done it once. Now we've got to go back and start with the copper amount. So let's start over now. We're going to have 100 grams of copper. First step, grams to moles. 63.55 grams of copper per 1 mole of copper. Now mole to mole ratio. 1 mole of copper corresponds to 2 moles of silver. Again, we're going from the coefficients in the reaction equation. And now we're going to go back to grams. 1 mole of silver is 107.86 grams of silver. And that gives us a whopping 339 grams of silver. Now, if we have these 2 possibilities, it's the smaller one that will actually result. Because at the point that 12.7 grams of silver have been produced, all 20 grams of silver nitrate are used up. And at that point, the reaction is going to come to a stop. All right. So now we don't have to worry about this calculation anymore. It's done. It's just a test to see how many grams of silver are going to get created. All right. And it's always the smaller of the 2 values that determines the amount. Okay. So we now know that silver nitrate is our limiting reactant. We know that copper is our excess reactant. All right. And now if we wanted to calculate back how much copper remains, we can start with either the 20 grams of silver nitrate or the 12.7 grams of silver. It doesn't matter which one you do, you'll get the same answer. I like to go back to the original. I find that many students prefer to do the 12.7. It completely doesn't matter. In this case, I'm going to do the 20. So the 20 grams of silver nitrate all gets consumed. I'm going to change that to moles. This time I'm going to mole to mole ratio over to the copper to see how much copper gets used. So for every 2 moles of silver nitrate, there's 1 mole of copper that is used. And since I want that in mass so I can subtract that from the 100, 1 mole of copper is 63.55 grams of copper. And that comes out to be 3.74 grams of copper. And that's how much copper is used in the process of using up all 20 grams of copper and making the 12.7 grams of silver. All right. So if that's how much is used, we know we originally had, initially, we had 100 grams of copper. So we can just subtract from that. We initially had 100. We can take the amount used, which was 3.74, and that's going to give us 96.3 grams copper that's present in excess. So if you were to do this reaction with these amounts, 20 grams of silver nitrate, 100 grams of copper, you'd see that very little of the copper gets used up. All the silver nitrate gets used up. You create a little bit of silver. All right. So this is the general process for calculating limiting reactants. Anytime you have 2 or more reactants that you have known amounts for and are not told that they're in excess, you have to do the calculation for each one, find the smaller value. From there, or from the original amount of the limiting reactant, you can work backwards to how much of the excess reactant is used and then subtract it from the amount present originally.